be 9i squared again.
Yes.
Ah.
Okay, 4.6. We're going to finish it. Okay, complex numbers. When we are dividing complex numbers, we cannot have radicals and we cannot have imaginary numbers in the bottom. Okay? So to get rid of that, we have to multiply the top and bottom by whatever this is, the opposite sign of it. So in this case, I need to multiply by 1 plus 4i. Because I want to cancel out the imaginary number on the bottom. Okay? So whatever you do to the bottom, you have to do to the top. Which means we have a lot of foiling to do. Okay? 7 times 1. 7 times 4i. 7 times 4 is 32. No, 28. So I get plus 28i. Then I have 5i times 1. So plus 5i. And then I have 5i times 4i. So I have plus 20i squared up top. On bottom, okay, a little trick is all you have to do is multiply this times this and this times this because the middles will always cancel. We did that on purpose so that the middles will cancel. So I do 1 times 1, which is 1, and I do negative 4i times 4i, which is negative 16i squared. If you have something on the bottom that still has an I in it, okay, and it's not a squared, you've done it wrong. Period. So up here, I'm going to combine like terms. I have 7 and I have 20 times I squared. What is I squared?
-1.
So what is this number actually?
So 1.
So negative 1 times 20 is?
-20.
So what is 7 minus 20? So negative 13. And then what's 28i plus 5i?
33i.
That's the top when I reduce it. On the bottom, I have 1 plus, because this is a negative 1i, right? Or this is a negative 1. So negative 1 times negative 16 gives me a positive 16. So I have 1 plus 16, which is 17. And that's your solution. Now, in the back of your book, they might break these fractions apart because they might reduce them. If you leave it that way, I'm okay with it. But sometimes they're going to break them apart because maybe this portion can be reduced, but this can't. And so it's going to show you different ways in the back of the book. Okay? How do I do the red one? 5 over 1 plus I. What do I need to do?
The top has to be the opposite. So it would be.
Yeah, the bottom has to be the opposite. So what do I need to multiply by?
Oh.
1 minus I. 1 minus I. Okay? So once again, now on top, I don't have to FOIL this time. I just have to do what?
Distribute.
Yep, so what's 5 times 1?
5.
And what's 5 times negative I?
-5.
Good. On bottom, remember I said just multiply the first and the last. What's 1 times 1?
1.
What's I times negative I?
-I squared.
Now, that means I have 5 minus 5i up top, and on bottom, what do I have?
I squared.
What is I squared?
-1.
So I have 1 minus negative, yeah. So I have 1 minus negative 1, which gives me a, so I have 5 minus 5i over 2. How do I solve 5 plus 2i over 3 minus 2i? How do I simplify that? Or do I
Just take the opposite of the bottom.
Okay, so multiply the top and bottom by what?
Close to I.
Okay. On this one, I have to. Okay. 5 times 3 is,
15.
5 times 2i is,
2i.
2i times 3 is,
6i.
and 2i times 2i is
4i squared.
4i squared. On the bottom, what do I have to multiply together?
3 times 3.
Yep, which is,
9.
and what else do I have to multiply together?
Negative 2i times 2i.
Which is,
Negative 4i squared.
now, up top, we're going to combine like terms. I have a 15, I have a 4i squared, which means what number do I actually have here?
Negative 2?
1. So then that becomes
Negative 2.
This is a negative 1, so this becomes what? What's negative 1 times 4?
Negative 4.
Negative 4. So what's 15 minus 4?
11.
11. So I have 11 plus 16i, because those are easy to combine. Now on the bottom I have 9, and I have an I squared here, which is a,
negative 1.
so what is negative 1 times negative 4?
Positive 4.
So it's 9 plus 4.
13.
And that's your answer. That's probably the hardest thing you're going to do today. Now, the next part is plotting the complex numbers, okay? You know how we plot stuff on the x and y axes? X is horizontal, y is vertical, correct? Okay. When we plot imaginary numbers, this is your constant. This is known as your constant, okay? And this is your imaginary axes. So this is your constant axes and your imaginary axes. This is my constant, this is my imaginary. This is my constant imaginary. That's why we have to write it in that form, because we can graph these, okay? So when I'm graphing 3 minus 2i, that means I go 3 on my constant axes, and I go down 2 on my imaginary axes, and I plot a point. Now, when you plot that point, I need you to label it 3 minus 2i. Okay? How would I graph b?
2 to the left.
Yep,
A 4.
and a 4. Good. And then I would label it negative 2 plus 4i. How would you graph c? Go up 3, yep. The 0 is my constant. And how would you graph d?
To the left 4 and down 3.
Beautiful. Does that make sense? That shouldn't be too bad. And when you have to graph them tonight in your homework, you can do them all in one graph. Just label them for me, okay? So you don't have to redraw graphs every time. Just put one graph and plot all of them on there. And then the last part we're going to talk about is finding the absolute value of something, of imaginary numbers. Here's why. The absolute value of a complex number is written in this form. It's written as z equals a plus bi. Okay, it's written in that form. Okay, where z is your absolute value. You're finding the absolute value of z. Okay, a z is a non-negative real number. Okay, so when you're finding the absolute value, you're going to be finding a real number. Okay? And it's defined as the absolute value of z equals the square root of a squared plus b squared. What does a squared plus b squared sound like to you? Pythagorean theorem. So we're using part of the Pythagorean theorem. Here's why. When you have a graph, this is your real axes, right? This is your imaginary. Okay. what happens is I travel one way on my real axis and I travel another way on my imaginary axis. Yes? Okay. So let's say I travel this way on my real, and then from here I travel up here on my imaginary. Right here, we then create what? A right triangle from that. Okay? So this is your a squared, this is your b, this is your c. You're finding this distance. That's what we're looking for when we're finding the absolute value of these terms. Okay? So that's why I'm using part of the quadratic formula. So when I go to find the absolute value, you're setting it up in this form right here, the square root of a squared plus b squared. What do you think is your a?
Your constant.
My constant is my a. And my b is what is in front of my imaginary number. So I literally am saying the absolute value of this equals the square root of -4 squared plus 3 squared. That's how you're finding absolute value.
So we don't do we actually find it, or we just
Yes,
write
we
it
actually
out?
find it. So what is -4 squared?
16.
16. And what is 3 squared?
9.
So I have 16 plus 9, right? Which is what?
25.
Square root of 25, which equals. How would I set it up to find the absolute value of this one? Do you have an A? No, so we just, it would be like having a 0 there. Okay, 0 squared plus -3 squared. What is this? What is -3 squared?
9.
So you have the square root of 9, which is
3. So if it has only
one of them.
then it's always going to be the positive form.
It will always come out positive because it's absolute value. Yes. Okay? So that is what you're working on tonight. You're working on complex numbers, getting rid of the denominators being in complex form. You're working on plotting complex numbers and finding the absolute value.